Assalamu alaikum.
Walaikum salam.
Okay, how are you?
Um, I'm all right. I'm all right.
Okay.
How are you?
Alright. So yesterday, I understand it's okay. I understand sometimes it's difficult to get up early in the morning. But why were you declining the calls? That's what
Oh,
made me like
'cause
really confused and anxious. Like, is everything okay?
I was
Uh,
I was currently asleep,
Okay,
so I
so
didn't.
you thought that was an alarm, I guess, right?
Um, no, my phone was like shut off. So, because I was in a group chat and the group chat kept on sending notifications like so I turned off the notifications and I went to bed and
Mm-hmm.
then I woke up at like 9:30 and looked at my
Mm-hmm.
phone. I was like, oh wait, that's not good. And then I talked to you and everything.
Oh, okay, I understand, but it was showing that the call has been declined multiple times. So why aren't you
Declined?
declining my calls? That means you were
No,
cutting my calls,
I don't think
isn't
I
it?
was cutting the calls. I don't think I was
That,
cutting.
that that's strange.
It says here, you missed call, missed call, missed
Yes,
call.
even if you cut my calls, it will show it's a missed call. Okay. Okay.
Oh,
If you don't receive my call, that would be a missed call. Okay. Anyway, so that made me really confused because I thought, okay, so if you can cut the calls, why can't you reply that, okay, bhaiya, maybe I'm sick or maybe I'm in some sort of a problem. So that is why I can't attend, something like that. Anyway, all right. So previously, we had some sort of confusion regarding the relative velocity. So let us first clear the concept of that first. Okay. So, okay, let me get to whiteboard to clarify that thing. So what is relative velocity? In simpler words, relative velocity is if there are two moving objects, if there are two speedy, it doesn't have to be always speedy or moving object. One of them could be stable as well. But for the better understanding, I'm going for, say, two speedy moving objects because if you understand that, you'll easily be able to understand when a particular object is like stable. Okay. So if there are two speedy moving objects, the velocity of one object with respect to with respect to the other object equals to relative velocity, right? With respect to or with relation to the other object. So from these terms, you could see that the term relative velocity comes. Okay.
what does it mean by with respect to the other object?
Okay, I'm coming to that. Okay. So for instance, here's a tree. Okay. As we have already read about reference frame. So let us create a reference frame here. So this is a tree. So this is a car. It's moving at 20 meters per second. And also, this is also a car. It's moving in this direction at 20 meters per second. Okay. Now, what is the velocity of the tree?
0 meters per second.
0 meters per second. And say this is car B and this is car A. Sorry, car A. Now, velocity of car B with respect to this tree would be 20 meters per second. Very easily we can understand. Whenever we are saying that, okay, I am walking at a speed of say 5 meters per second. So now we have to like mean with respect to something. That is, the other things beside us are static. Say, for instance, a building maybe the road is static, maybe other things are static. With respect to that, we are moving at a speed of 5 meters per second. Okay. Same goes for the tree. This tree is static. With respect to that, our car speed is 20 meters per second. Okay. Now, if we consider for an observer, say here is a driver in this car A, what do you think? If the car A is going in this direction and it sees the car B coming from the opposite side, do you think that car A will feel that the car B speed is 20 meters per second? What do you think?
Um, no.
It will feel like it's coming in more faster pace, right?
Yeah,
It will
40
feel
meters per
like,
second.
yes, exactly. It will feel like 40 meters per second. So you have understood the difficult part already. All right.
Yeah.
So it will feel like it's 20 plus 20 equals to 40 meters per second. Exactly. Now, if we see another scenario, that is two cars are moving in the same direction. Okay. Let's say it's going at 10 meters per second. And also, this is also moving at 10 meters per second. Say this is car C and car D. Now, what do you think? What will an observer of car C feel like? Like, will it see the car D speed to be 10 meters per second?
No, see, 0 meters per second.
0 meters per second, right? Exactly. Okay. So, you are getting the idea quite clearly. So, from these two examples, what you see is whenever it's like coming from the opposite direction, the speed is being added, and whenever it's going in the same direction, the speed is being subtracted. So, what is the significance to that? The significance of calculating relative velocity is that just let me check once. So, so with respect to which, okay, say for instance, it is the relative velocity of car A with respect to car B. For whichever respect you are calculating the relative velocity, you have to turn it 180 degree. Okay. Say for instance, this is 20 meters per second and you are calculating the relative velocity with respect to car B. You have to shift it 180 degree. That is, it will go in this direction. That is, this is 20 meters per second. Okay. All right. So now, if you calculate the resultant or the relative velocity, it will become 20 plus 20 because the alpha is 0 degree. I'm coming back to that point as well. Okay, but still, let me check because I made some kind of mistake here. Okay, all right. Okay, all right. It's correct. No problem there. So, you are calculating the relative velocity of car A, okay, with respect to car B. So you are calculating with respect to car B, so it will get reversed, or you will like uh, turn it or shift it 180 degree. Okay. Now same goes for you are calculating the relative velocity of car C with respect to car D. So you will shift it 180 degree. Okay. Now you can easily understand why the observer of car A feels like that the like car B is coming at a pace of 40 meters per second, and why an observer of car C feels like the car is coming at 0 meters per second. Understand?
So if you see this mathematically or algebraically,
Mm-hmm.
pretend that going to the right is positive and going to the left is negative. You can say that
Right.
20 plus 20 equals 40 meters. So car A is seeing the thing as
Yes, yes,
40 meters.
yes.
And then
But
10
the
plus minus 10.
10 plus minus 10. But the thing is, it's not going to be that easy because not all the time are we calculating the relative
It's never
velocities
easy.
like if, say in the left and the right or up and the down. Okay, there can be angles as well. Okay, so the basic concept for calculating the relative velocity is basic concept is turn the velocity with respect to which turn 180 degree actually turn 180 degree the velocity with respect to which you will calculate the relative velocity. Okay. So this is a very key point that with respect to, okay, see, you don't turn the car A's velocity. Okay, you are uh, calculating the relative velocity of car A with respect to car B. So that is what you are going to shift or turn. Car B, you are going to shift. Okay. All right. So you have to be very careful about that. Even I checked it twice because there is a huge chance of like confusion. All right. Okay. Is it clear up until now?
Yes.
Okay. Good. Now, say it's not all the time that we will get to see that the angles are like 0 degree or say maybe 180 degree. So let's consider a thing. This is u meters per second. Say this is object A. Okay. It's object A. So object A's velocity is u meters per second to the right, you could say. Object A. And this is object B's velocity. Object B. This is v meters per second. All right. Now we want to calculate the velocity of object B with respect to object A. Okay. What did I say? Calculate the velocity, relative velocity of object B with respect to object A. And the representation to that is velocity of B. Okay. And then you are going to write with respect to what? Okay. So it represents. So say for instance, whenever we were writing say VC, it is velocity of C, VD, velocity of D. And then after that, say if you write say X, it will be velocity of D with respect to X. So same here, velocity of B with respect to A. Understand?
Yes.
Okay. Again, I would say this be careful with this notation because you might get confused with this as well. Okay, so first of all, of relative velocity of what, and then later with respect to what. Okay, so with respect to A and velocity of the first object, which is B. All right. So now let's try to calculate it. All right. So let us consider that the angle between object A and object B is alpha. Okay. You can draw a newer picture as well if you want. So now you will tell me, we are calculating the relative velocity of which object?
A.
No. Read the
Wait,
question again. Calculate the relative velocity of
B.
object B. Okay, all right. And with respect to which object?
A. Okay. Sorry.
Okay, all right. So we have to turn which object? Tell me.
A.
Exactly. To the left, or that is 180 degrees. Okay, so let us 1 second.
Yes.
All right. So let us shift. Okay, let me draw it. So we have shifted this u, say, you could say minus u, but it doesn't matter. Okay, because the angle will automatically change. So let us just consider the values here. Okay, forget about the directions or the something. Okay, for the time being, let us just consider the directions. Okay, now we have changed the direction of it. Okay, now what do you think if we are calculating the relative velocity? Obviously relative velocity is also a resultant velocity. There is no confusion in that, right? Relative velocity is a resultant velocity, right?
Yes.
So now what do you think? Where will the resultant of the object be, like v meters per second, and we have shifted the object A to the left? Where should it work like? What do you think?
I
Shouldn't
don't
it
really
work
understand the question.
between something somewhat between here?
In the middle? Yeah. The middle.
Not in the middle. We don't know the angle. We will calculate the angle. Okay. So it will work somewhat like in this direction. Okay. Is it clear what I did here?
So that fourth line with the two arrows, that is the resultant vector.
Yes, resultant vector. It's not a force. It's a velocity. It,
Sorry.
it's
Sorry.
not necessary that all the vectors in the world are force, right? Here we are calculating velocity. Okay. All right.
True.
So, and we will represent it with V, B, and A. Okay. All right. So now, we also need to take a note of the angles. So tell me, what is this angle?
1 second. Angle.
Yes,
That is the green one, the red one.
a green one. Red one is already I've mentioned.
180 minus alpha.
Good, very good. 180 minus alpha. All right. So now very easy. So VBA equals to the formula we have used previously. It will be u squared. Okay. Let us not write u squared. Let us write VA squared. Okay. So VA squared plus VB squared. Okay. Plus 2 times VA times VB times cosine of 180 minus alpha. Okay. Is it clear? Like it's the same p squared plus q squared plus 2p cube cosine alpha. I have just like replaced p and q with v and vb, nothing else. Okay. And the
Wait,
alpha has turned into 180 minus alpha. Yes. Right.
B. Oh, wait. B is the. Okay, no, I got it. I got it.
All right. Mhm. So now this is just the relative velocity. Okay. Nothing has changed. This is same thing. Okay. There is like no change at all. You might ask. Okay. All right. And there will be, sorry, a square root would be there.
Yeah, I was
Would
thinking
be-
that.
Okay. Mhm. Okay. And we have to calculate the theta. So, or the direction. Say we are taking the theta with this, I mean, say VA. So that means tan theta will be equal to this U or VA will go down in the bottom left corner. Okay. And then we are taking VB sine. What is the angle? 180 minus alpha. and VB cosine 180 minus alpha. Now, sometimes you will find in the book written as like sine 180 minus alpha equals to like plus sine alpha, and cosine 180 minus alpha equals to minus cosine alpha. However, I would suggest that it's not important because we are doing physics here. So alpha would be given to you. So like don't bother about changing the signs. Okay, whenever you are doing trigonometry, you can change the cosine 180 minus alpha. Okay, minus cosine alpha, or sine 180 minus alpha equals to sine alpha. But you can note it down. Say sine 180 minus alpha equals to sine alpha, and cosine 180 minus alpha equals to minus cosine alpha. Okay. So, let me know when you're done.
Done.
Okay. So these are all the equations and understanding you needed to understand about relative velocity. And this is particularly very interesting understanding, and also, I mean, when you will see the maths, you will find it more like, what can I say? Beautiful, I guess. All right. Okay. Now let's get back to the previous day's maths. Okay.
Oh no.
Okay. Can you see my screen now?
Yes.
Okay. So now see, a car is running at 40 kilometers per hour towards east. Okay. So car is moving towards the east. And the driver of car sees a truck running at 40 root 3 kilometer per hour towards south. That means it is the relative velocity, right? It is the relative velocity. Okay.
Yes.
In which direction really the truck is running, and what is the actual velocity of the truck? Now, VTC, that means the velocity, relative velocity of truck with respect to car, with respect to car. Now that what that means is, forget about this diagram. What that means is we have to shift the car 180 degrees like this. This is our VC. Okay. Now tell
Okay.
me, if this is VC and this is the resultant, that means the other vector, it should work in somewhat in this direction. Are you understanding it now?
Yes.
Otherwise, the resultant can't work in this direction, right? It has to,
No.
I mean, work in this, sorry, the velocity of track, or the actual velocity of track has to go in this direction to keep the resultant working in this direction. Understand my point?
Yes.
Okay. So this is how the whole system forms. I think they have like shifted these vectors and all because we don't have the understanding of the relative velocity up until this point when you are reading the vector chapter. When you will get into dynamics, you will get better idea of relative velocities. But we have already understood that, so we will do in this way. Okay. So is it clear now that how the system forms? Say, forget about that diagram. So car is running at the east. So let us draw it in the east. And it sees a car running at 40 root 3 towards the north. Okay. So this is VTC, velocity of truck with respect to car. Okay. Which equals to 40 root 3. And then we have to shift the car to this direction. Okay. VC equals to 40. And obviously from that we understand that if the resultant has to work in the middle, that means in the right there should be a velocity, which is the velocity of the truck, actual velocity of the truck. And from that, we can easily calculate the velocity of the truck. How? That is by like applying the formula. Is it clear now? I know that there were some bloody things the previous day, so I hope it's clearer now. Okay. Actually, I didn't know that out of the blue, relative velocity will come into play in this chapter. So I was a little surprised at that time. So I checked about relative velocity. So yeah. All right. So is it clear now?
Yes.
I think it should be clear. Okay. All right. So now again, same way, a man while running at a velocity of 4 meters per second comes across rain falling vertically with velocity of 6 meters per second. Okay. Now, see, the man is running in this direction and the rain is falling obviously vertically downwards. All right. Now, this is a V man and this is a V rain. Okay. So now, to understand in which direction he or she uh, has to hold the umbrella, we need to understand what will be the relative velocity of man with respect to, sorry, relative velocity of rain with respect to man, right? Relative velocity of
Yes.
rain with respect to man. What did I say? Relative velocity
Of rain with respect to man.
rain with respect to man. Now, what is the notation to this? The notation would be V R and with respect to M. Okay, very good.
Okay. So that's just like
Now,
the whole
yes,
statement question is shortened into VRM, velocity
yes,
of rain with
you could
respect to
say
man.
that. That
Okay.
is what we do, so for
Yeah, that makes
solving
sense.
anything,
Yeah.
because it makes it easier for us to understand, right? Okay, so now that means we have to shift this Vm exactly 180 degrees Vm. And what is the velocity of the man? That is 4 meters per second. Okay, and to apply the parallelogram formula, what we understood that for parallelogram formula, from a particular point, two vectors have to go in separate directions, right? From one particular point, one vector
Yes.
went in this direction and one in this direction. So that is why we are going to extend this VR vector a little downward. We haven't changed the direction, right? We haven't changed
No.
the direction. Okay. So that is why what we are doing is just like extending it. So there is no problem there. Okay. So VR, you can do that. That is what I'm saying. So it is 6
Oh,
meters per
cool.
second. So now the relative velocity will work somewhat in this direction. We don't know in which direction it will be in this direction. Okay. Sorry. This is not the, sorry. Wrong notation. This is not the like resultant velocity.
That's just the resultant. That's the,
Like
yeah.
actual. This is the actual velocity. Okay.
Yeah.
All right. So now, this is 6, this is 4, and the angle is 90 degrees. Okay. And we have to calculate VRM. Okay, now you will calculate it and let me know the angle and let me know the value as well. Okay. You can do it by yourself.
Sorry, what now?
You let me know the value of VRM and the angle, or the direction. Okay.
Okay. Wait, so I'm just gonna talk through this just to see if I'm on the right track. Um,
Yes.
so VRM is equal to square root of 4 squared plus 6 squared plus 2
Mm-hmm.
times 6 times 4 times cos of um 180 plus alpha. No,
Why 180 plus alpha?
because
We have already shifted the vector, right? That is the velocity
yes,
of man. We have shifted this vector. That means this will be our alpha, right? What is alpha?
yes.
Alpha
So
means the angle between the working two
two
vectors, right?
vectors.
Right. So
Yeah,
this is alpha.
but so
Yes, good.
it doesn't actually have to start from the angle zero. So it doesn't have to be like anti-clockwise or anything.
No, no, no. It's not that.
Oh, okay, cool.
Why is
All right,
that?
then.
Because see, let me explain that to you as well. Because what is the formula? This is 2pq cosine alpha. Okay. So if you have, I don't know if you have read in trigonometry or not, you would see that even if you use a calculator, that is cosine minus 30 will be equal to cosine 30. Okay. That is why if you take it clockwise or anti-clockwise, it does not matter. In this case, in this case. But if it had an involvement of say sine ratio, then it would have mattered. All right. Okay. But I would suggest that whenever you are calculating, calculate in the anti-clockwise direction for your safety.
Uh, uh,
So you should have gotten the answer by now.
so at the end it would be cosine alpha.
Yes, yes, cosine alpha.
Okay, so then okay, but and the value of cos of alpha would be 90.
Value would be 0, alpha would be 90.
Value is zero.
Yes.
Yeah, okay. Let me just put that in the calculator real quick. Ow.
So the square root of 52, that is somewhat
10
around
over
7.2, something like that. Right? 7.2, around 7.2.
yeah.
Okay, good. All right. And what about the direction? That is,
So 10 theta,
yes, tan
which is
theta.
equal to um um 4 sine 4 sine 90, and then which is over 6 plus 4 sine 90.
In the denominator, we use cosine, and in the numerator, we use sine, right? As is
Oh,
the
what?
formula for tan theta. Tan theta equals to sine theta upon cosine theta. Okay, this is how you should remember it. Otherwise, you might make a mistake. All right, and which one did you choose to be theta? This one or this one?
Um, that one.
Green or red? Green or red?
V green.
Okay, this one. This one is theta. So that means you have done it wrong. Because if you chose this to be theta, then in the bottom left corner, this 4 will go. Okay, understand? Be very careful about that. Okay, there is no like, I have already made you understood all the formulas and all. Okay, this is just about memorizing. That is why I've been saying from the very first day that the angle of theta with, say, it has to be it has to lie with one of the vectors, one of the two vectors. So whichever vector is lying, it is lying with, put it in the bottom left corner at first. Okay.
So the
And then with the
adjacent.
other vectors cosine alpha, sorry, sine alpha in the numerator, that is 6 cosine alpha, and then plus 6 sine alpha. Okay. All right. So
So
then you look
the
at the
4 is technically the adjacent side.
yes, yes, adjacent side. Yes, yes, you're correct.
Okay, so okay. So the adjacent side goes on the bottom and the hypotenuse side goes on the top. Not the
There is
hypotenuse,
no
the
hypotenuse side.
R.
Opposite
Yeah,
side.
sorry.
I mean, I won't say anything. I mean, whichever way you feel convenient with remembering, you can apply that for thing. All right. But I have said which helped me most. That is like the angle theta lies with one of the vectors. Just put it in the bottom left corner, and then we are done with that vector. And with the other vector, we put the cosine alpha in the numerator and plus sine alpha in the denominator. Okay. This is how I remember or memorize. Okay. Because if you like, if you just change the formula, then everything gets messed up. Okay. All right. The whole angle is changes. All right. So you might understand everything and all, but you will be unable to explain it to your teacher. Anyway, okay, this meeting is about to end. Let me give you another link. Okay.
Okay.